trying to understand the difference between convection, conduction, and radiation. Let's imagine with a very simplified 5 particles. And imagine I gave this particle on the left some energy. So perhaps these are particles in a block of iron, or maybe a block of anything, something solid anyway. Maybe not metal actually, because it gets more complicated when you look at metal. But a solid anyway. I heat up the other side. This arrow represents heat. When I do that, this particle gets a lot of energy and it vibrates and shakes around. In doing so, the energy is passed on to the next one, and this one starts to vibrate as well. Okay, that passes on to the next one, and so on. And it keeps going on and on and on. Now, if you pass the particles stay where they are, they just move around and they pass the energy from one to another. This is conduction. What I've just described is conduction. So we could say the thermal energy transfers from one molecule. It doesn't necessarily be molecule. I think I would leave it just as particle, because it might be an atom, might be a molecule, but particle is a better word to use because it's more general. So that's. Oh, wait a second. I grabbed convection. I meant to grab conduction. Sorry, that's conduction. Okay, so what I've just talked about is conduction. Let's just move conduction at the top. I'm just going to, let's leave that empty. Good. So what about the next one would be radiation. If this was not a solid but a liquid, then these particles would be able to move. So we'll just get rid of these little vibration things here. Now, they can all move and flow by each other. So this one could move over here, and if this is a liquid, maybe they would all move that way. Perhaps, another way we could think about it is, let's just get these back again. Imagine they were they were that way round. I'll just make it a little bit smaller. And I was heating them from the bottom, like you would do it if it was in a beaker. And I heat the bottom one, and it moves, has lots of energy, it's moving all over the place. And because it has more energy, it needs more space, so it moves towards the top. And when it moves towards the top, the other ones fall down, and this one goes in the space at the top. And now this one is being heated, and this one moves all over the place, and then it needs more space, so it goes up to the top, and they all fall down. And then this one goes to the top. Now we could show that this has more energy by maybe colouring it in. So we could say that this one is now is maybe red, and this one is red. And in fact, we could maybe be even more precise, and we can make this one. This one is now cooled down a little bit. It's lost some energy, so we can maybe make it, I don't know, pink or something like that. And then this one is now moving around. This is convection. And a way to describe convection is that the particles themselves move and take the energy with them. If there is gravity, which there usually is, the hot or the more energetic particles will move upwards, and the heavier, less energetic particles. Okay, and I'm making leading to a misconception here. The particles aren't heavier, but there's less. They're less. Okay, I'll tell you what. I'm going to leave that out. And we'll talk about that in a bit more detail later on. The more energetic particles will move upwards. We'll not talk about why they do that. We'll just simply say that the particles themselves move and take the energy with them. If there's gravity, the more energetic particles move upwards. But if there's not gravity, we can still call it convection because the particles are taking the energy with them and they're moving around. If they pass the energy from themselves to another particle, now we're talking about conduction. So usually you'll get all three transfers happening at the same time. But what I've just described is convection. So that's convection. And now we have the last one would be radiation. So what about if I stopped heating these particles altogether? We know that, and let's imagine that there is nothing around them to give the energy to. So there's no walls, it's not convecting, the particles aren't escaping. They will still get colder. For example, if you had a very, very hot, let's imagine you had these particles in the middle of space in a vacuum and there's nothing around in outer space, they will still lose energy. And this time they will lose energy as waves. So the radiation is waves. Whoops. This and of course, if there was another particle over here, or maybe a few particles over here, then these particles will absorb that energy, and they will start to heat up. So now they will be hot. So energy transfer. So radiation is when thermal energy is transferred via electromagnetic waves. Now, usually this is infrared, but hotter temperatures. Can emit visible light. And we know this because we see things that are very hot, they're glowing red, aren't they? And if they're even hotter, they might be white hot. But they can even be like extremely hot would give out ultraviolet. So emit visible light or ultraviolet. And actually, you can keep going hotter and hotter and hotter. But anyway, for that purpose, we'll just say this. So so this is what radiation is. Okay. Does that make sense? Okay, good. So let's just squash that there. So those are 3 different heat transfers. Let me just stop that video and we'll just put that there.